So last lesson we talked about the equation of a line given a slope and a point. Today we're going to be talking about the equation of a line when you are only given 2 points. So quick recall, given a line with a slope of -3 and passing through the point 1 and 2, find the equation of the line. Well, I'm going to use that slope we have, y equals -3x plus b. I have my x and my y. So I plug those values in. 2 is equal to -3, my x value is 1, plus b. 2 equals -3 plus b, which then gives me a b value, or my y-intercept. If I bring that 3 over, it becomes +3, which would be 5. So then my equation of the line, y equals -3x plus 5. Right, so that was what we talked about last lesson. Give you a slope, I give you a point, or you're given a slope, you're given a point, and how do you determine the equation of the line? So a quick recall before we get into today's lesson of finding a line with 2 points. So given 2 points, A and B, and they're labeled as A has a coordinate of an x and a y, or x1, y1, and B has a coordinate of x2, y2. The slope of the line passing through the point is, well, slope can be written as the change in y over the change in x, which we know to be y2 minus y1 all over x2 minus x1. So on the graph here, there's my A and there's my B, and the line that would pass through them would look kind of like that. And then we would know that the change in the run here and the change in the rise, right? So this would be x2 minus x1, and this would be y2 minus y1, right? So the general idea of finding a slope using 2 points, that's kind of how we would do it. That should be a bit of a refresher. So if we find the slope of the lines passing through the points 4, 5, and -2 and 8, well, I first need to find the slope of this line. So I'm just going to quickly label this as x1, y1, and this is my x2, y2. I know the equation of slope. Slope equals y2 minus y1 all over x2 minus x1. The values that we have in this case, 8 minus 5 all over -2 minus 4. Right, so we have our y2 is 8 minus 5, y1, x2 is -2 minus 4. So then I go ahead and perform that math. I end up getting -3 over 6. Now you could have got 3 over -6. Either way, the slope is negative. And then how will we reduce that? Well, 3 over 6 can be reduced to 1 over 2. And we know that the slope is negative. So the slope of the line passing through those 2 points is -1 over 2. So when we're finding an equation of a line given 2 points, there are a few steps that we have to go through, right? So I'm just going to quickly label this point A, and I'm going to label this point B. So first step, we're going to find our slope. So our slope is equal to, well, y2 minus y1, in this case 10 minus 2, all over x2 minus x1, 5 minus 1, which gives me 8 over 4, which can be reduced to 2. So the slope of this line is 2. Now, this should be ringing some bells from what we did last time. We now have a slope and we need to find the equation of a line, and we have points. So we just get to choose which one we'd want to use, right? So if I go ahead and use line A, for example, I'm going to plug in the value of line A. So y equals 2x plus b. My a value, my y is 2, and my x value is 1. I end up getting 0 as my y-intercept. If I plug in the value of b, y equals 2x plus b. I plug in my y value of 10, my x value of 5, plus b. I end up getting 10 is equal to 10 plus b. My y-intercept value is then 0. So it doesn't matter which point you use, either this one or that one. Once you determine the slope of the line, because that's all you can figure out from these 2 points, you then choose a point to plug in to the equation of a line and solve for your y-intercept. In this case, I use both just to kind of prove that no matter which one you put in, you're going to get the same answer. So then the equation of the line, y equals 2x. If you wanted to, you can put plus 0, but we know that that doesn't necessarily need to be there, so we can go ahead and eliminate that. So that would be the equation of that line. Another example, line passes through -3, -2, and 6 and -8. So first step, I need to find my slope. Slope equals -8 minus -2 all over 6 minus -3. So this then becomes -8 minus -2 becomes -6. 6 minus -3 becomes 9. -6 over 9, I can reduce that to -2 over 3. So I now have my slope. Go ahead and plug in either a value, either this point or this point. Y equals -2 over 3x plus b. So we plug in, I'm just going to use the first point here. I'm going to use this one. So my y value is -2 equals -2 over 3. My x value is -3 plus b. Well, this -3 can be written as over 1. So I have -2 over 3 multiplied by -3 over 1, which can be simply written as -2 is equal to 6 over 3 plus b. Well, 6 over 3, or 6 divided by 3 is 2. And then -2 minus 2 becomes -4 is equal to b. So then therefore, the equation of this line is y equals -2 over 3x minus 4. So you can find an equation of a line if you know 2 points on the line. So to find the equation, find the slope by substituting the 2 points into the slope formula, y2 minus y1 over x2 minus x1. The second step, find the y-intercept by substituting the slope and one of the points into y equals mx plus b, and then solve for b. And then write the equation by substituting m and b into your equation. So these 3 things right here basically sum up what we just proved up top, and kind of makes it a little bit easier to follow along in terms of what it is you need to do in order to find the equation of a line given 2 points. So we got into some word problems. Third example, or example 3, a taxi company charges a fixed base cost and charges a variable cost per kilometer driven. So it costs $32.50 for a 10-kilometer trip, and it costs $53.50 for a 17-kilometer trip. So when the distance is 10, it costs this much. When the distance is 17, it costs this much. So if I'm just going to quickly state these variables here, I'm going to say my x is distance, my y is cost. So what is the variable cost per kilometer? Well, if you think about it, I have an x and a y value. I have another x and a y value. So these are 2 points. So if I go ahead and plug those into my slope equation, slope equals y2 minus y1 all over x2 minus x1. My y values in this case is the cost. My y value is the cost. So this is my second y value and this is my first y value. So I would have 5350 minus 3250. 5350 minus 3250. And my x values, well, my second x is 17 minus 10. So if I have 5350 minus 3250 all over 17 minus 10, I end up getting 3. So that means the cost is $3 per kilometer traveled. Find an equation for the line relating the cost of a trip, represented by C in dollars, to the number of kilometers driven by N. Or the equation is cost is equal to the rate of change times the number of kilometers driven plus B, which would be our initial cost. So we know our slope, right? So we actually know what the M value is. Do we have an N, which would be N is kilometers driven, and then C is cost? Well, yes, we do. That's technically our X and our Y. So if I plug in any point, I'm going to use the first one that they gave us. I'm going to use this one here. So if the cost is equal to MN plus B, my cost is 3250 is equal to my slope is 3. The distance of this trip was 10 plus B. All right, so I'm trying to find the B value, or in this case, the initial fare that it costs just to simply sit in the cab. So I go ahead and do the math here. 3250 is equal to 30 plus B. Well, then 3250 minus 30, 250 is equal to B. So that means the equation would be Y is equal to, what's our rate? $3 per kilometer. 3N per kilometer, number of kilometers, plus a $2.50 base fare. What does the C-intercept represent, or basically what we just talked about? It represents starting cost, or the initial cost. Initial cost, or base fare, whichever. Use the equation to find the cost of a 23-kilometer trip. Okay, so the equation that we're using, the one that we came up with, cost is equal to 3N plus 250, $2.50. 23 kilometers, so that would be the N value. We're trying to find the cost. So the cost, it would be equal to $3 for every 23 kilometers plus $2.50 base fare. We end up getting 3 times 23 plus 250, 71.50. So therefore, it costs $71.50 for 23 kilometers. Right? Slightly different example. Kent knows that last month it cost him $32 to visit his gym 7 times. He forgets what the fixed monthly cost is, but he remembers that the variable cost is $2 per visit. Right? So he doesn't know how much it costs basically every month, but he knows that every time he goes to the gym, it's going to cost him $2. Find the fixed cost and write an equation that relates the cost in dollars to the number of visits. Well, let's kind of state our variables here. So we state our variables. Our independent variable, let x equal number of visits, and then y is going to equal cost. We know, what else do we know? We know that the variable cost is $2 per visit. So we know that the slope is 2. We're trying to find initial cost. We don't know it. And then do we have anything else from this equation that we can kind of pull out? We know that the variable cost is $2 per visit, so the slope is 2. We've stated that x is number of visits, y is our cost. We don't know what the initial value is, but we have something here, $32 to visit his gym 7 times. So we have a point. When x is 7, y is 32. So when he showed up 7 times, it cost $32. So that's another piece of information that we need to know. So a point we have is 7 and 32. So the equation that we would use, cost is equal, our rate is $2 per number of visits plus b, right? We don't know what the monthly or the initial cost is. Plug in our value, so the number of visits was 7, and it cost him $32. Go ahead and perform the math. 32 equals 14 plus b. I end up getting 18 is our b value. So then therefore the equation, cost is equal to $2 per number of visit plus 18. Go ahead and graph the linear relation. So we see here that we have our number of visits on the x-axis, our cost is on the y, our scale here is going up by 3, so we know our initial value is 18, so that's where it's going to start. And then the rate of change is 2, so it goes up 2 over 1. So it would look something like this, very, very rough, like this, right? So long as we know that the start value of this membership is $18, and then it's $2 every month from then on. So if Ken paid $40 in 1 month, how many times did he visit? Well, we know our equation, cost per visit is equal to $2 for every visit plus $18. We know that it cost him 40, so that would go here. 40 is equal to 2n plus 18, right? We're trying to find the number of times that he visited. So we're actually trying to find our n because we know it cost him $40, so that's where the 40 would go. So I then need to solve for my variable of n. So I would have 40 minus 18 is equal to 2n, which would then give me 40 minus 18 is 22 equals 2n. Divide both by 2, n is the value of 11. So therefore, he went 11 times. So hopefully this kind of, you can see how it builds on from our last lesson, which would be slope and point. The only difference is, if I go back to these 3 points, I actually do a pretty good job of these key concepts here. The only thing that we really need to do is we're adding the step of having to find the slope. So this is the new step, right? Last lesson, it was here's a point and a slope, solve for b, and then write the equation. Now, you'll be given 2 points. We need to find the slope, then use that slope and find the y-intercept. And then once you've found both of those, write the equation by substituting m and b into our slope-intercept form of